Have you ever wondered how small can things get in our universe? Let's dive into the realm of quantum physics, the branch of science that delves into the infinitesimally small. Here we encounter a world that follows a different set of rules. At this scale, we meet the Planck length, the smallest theoretical measure of length, unimaginably tinier than even a proton. Named after Max Planck, the father of quantum theory, it's a scale at which space and time cease to exist as we know them. Then there's the concept of quantum foam, another mind-boggling prediction of quantum mechanics. It suggests that at the Planck scale, the fabric of space-time is not smooth, but boiling and frothing like bubbles in a pot of water. In this realm of the quantum, reality as we know it starts to warp and twist. So that's how tiny things can get. But what happens when we start to scale up? Moving up from the quantum world, we enter the realm of atoms and molecules. These tiny particles, although larger than quantum particles, are still incredibly small. Imagine this. If you could line up 1 million atoms, they would barely span the width of a single human hair. Yet, despite their minuscule size, atoms are the fundamental building blocks of everything. They come together to form molecules, which in turn create the vast variety of substances and materials in our world. Consider water, a molecule formed from 2 hydrogen atoms and 1 oxygen atom. It's a simple combination, yet it's vital for all known forms of life. Or take a diamond, one of the hardest materials known to man, made entirely from carbon atoms arranged in a specific pattern. It's fascinating to think how these microscopic entities shape our macroscopic world. Atoms and molecules build everything we can touch and see. But what about the things we can't touch or see, like air and light? And beyond the world of atoms and molecules, we find ourselves in the macroscopic world. This is the realm we're most familiar with, where we interact with objects, people, and geographical features on a daily basis. From the tiny ant crawling on the ground to the towering Mount Everest, this is the world that we can touch, see, and experience. These objects and beings, vast and varied, are composed of trillions upon trillions of atoms and molecules. Each person, each tree, each grain of sand is a bustling metropolis of atomic activity. Consider our planet Earth. It's about 8,000 miles in diameter, home to over 7 billion people and countless other forms of life. And yet, every organism, every mountain, every ocean is made up of these minuscule building blocks we've been discussing. Earth, our home, is a massive entity, but in the grand scheme of the universe, it's just a speck of dust. Leaving behind Earth, we venture into the vastness of space. As we journey away from our home planet, we soon realize that even our solar system is but a tiny speck in the grand cosmic canvas. The sun, the centerpiece of our system, is just one of the estimated 100 billion stars swirling in our galaxy, the Milky Way. The distances here are so vast that we use a unit called the light year, which is the distance light travels in 1 year, roughly 6 trillion miles. Even within our own solar system, these distances are mind-boggling. For instance, Neptune, the furthest planet from the Sun, is approximately 4 light hours away. As we zoom out further, we find that our Milky Way galaxy is just one of the estimated 2 trillion galaxies populating the observable universe. The nearest galaxy to us, Andromeda, is a staggering 2.5 million light-years away. The observable universe, the grandest scale currently known to science, is a sphere with a diameter of about 93 billion light-years. That's the distance light has traveled since the Big Bang occurred around 13.8 billion years ago. This huge discrepancy is due to the expansion of the universe. Light from distant regions has had to travel increasingly longer distances as the universe has expanded. The sheer scale of the cosmos is humbling, to say the least. It's a vast, intricate tapestry, woven of countless stars, galaxies, and clusters, each with their own stories, their own histories, and yet despite the unimaginable vastness, everything in the universe, from the smallest particle to the largest galaxy, is connected, bound by the same physical laws and principles. From the tiniest particles to the vast expanse of the universe, the scale of our universe is a testament to its grandeur and complexity. So we've journeyed from the quantum world to the cosmic scale. We've seen the tiniest particles, quarks and neutrinos, and explored atoms and molecules that make up everything around us. We've marveled at the macroscopic world we inhabit and gazed in awe at celestial bodies light years away. The scale of our universe is indeed mind-boggling, a testament to its endless possibilities. Next time you look up at the stars, remember, You're a part of this incredible universe, from the smallest atom to the largest galaxy.